So welcome students. So in this question, you're asked to find sigma n is equal to 1 to infinity cot inverse of 2 sigma k equal to 1 to n k minus 1 by 3. So how do we go about doing this problem? First, let us try to simplify this expression. You know what this expression is? Sigma k equal to 1 to n k is nothing but n into n plus 1 by 2. So you have a formula in series and sequences where you say that k equal to 1 to nk is nothing but 1 plus 2 plus 3 up to n is n into n plus 1 by 2. So what is 2 times this? 2 times this is nothing but 2 times this, so this gets cancelled. So this sigma becomes n is equal to 1 to infinity cot inverse of n into n plus 1 minus 1 by 3. So this can be written as sigma n is equal to 1 to infinity. I am more familiar with tan inverse than cot inverse, so I will try to convert this into tan inverse. So this is equal to tan inverse of 3 by n square plus n minus 1. N square plus n minus 1. Now what I try to do is I'll try to split this tan inverse into two parts. I'll try to express this as tan inverse of something minus tan inverse of something. So what is the formula that I have? Tan inverse of x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy. So I'll try to convert this into this form. So if I have to try to convert this into this form, so in the denominator I have to have 1 plus something. So I'll try to write n square plus n minus 1 as 1 plus something. So what is this? What is 1 plus something? So n square plus n minus 2, right? So n square plus n minus 1 is 1 plus n square plus n minus 2. That is equal to 1 plus. So what does this become? So can I factorize this? It is nothing but n plus 2 times n minus 1, right? So n plus 2 times n minus 1 is n square plus 2n minus n is plus n minus 2. So now I have converted the denominator into this, and for this formula to work, the numerator should have exactly the difference between these two terms. Whatever terms you get, the numerator should have exactly the difference between these two. So does 3 satisfy that? So can I write 3 as n plus 2 minus of n minus 1? Luckily yes. See, n plus 2 minus of n minus 1 is n and n gets cancelled, so 2 plus 1 is 3. So this can be written as sigma n is equal to 1 to infinity tan inverse of, so 3 can be written as n plus 2 minus of n minus 1 divided by 1 plus n plus 2 times n minus 1. So do you see that this is of the form tan inverse of x minus y by 1 plus xy? X minus y by 1 plus xy. So I can express this as sigma n is equal to 1 to infinity tan inverse of n plus 2 minus tan inverse of n minus 1. So tan inverse of n plus 2 minus tan inverse of n minus 1. So effectively what did I do till now? I have divided one tan inverse into a difference of two terms. So now let us try to sum these terms. So now let us put n is equal to 1. So if I put n is equal to 1, the first term is nothing but, so tan inverse of 3 minus tan inverse of 0. Second term is tan inverse of 4 minus tan inverse of 1, right? If you put n is equal to 2, you have tan inverse of 4 minus tan inverse of 1. So T3 is equal to tan inverse of 5 minus tan inverse of 2. So till now there is no cancellation, but let us see what happens now. So tan inverse of 6 minus tan inverse of 3, T5 is nothing but tan inverse of 7 minus tan inverse of 4, so on. So as you go, you get Tn as tan inverse of n plus 2 minus tan inverse of n minus 1. So now do you see that you get cancellation after 3 terms? So tan inverse 3 minus tan inverse 3 get cancelled. Tan inverse 4 minus tan inverse 4. So if you write the next term, tan inverse 5 minus tan inverse 5 gets cancelled. So on, things get cancelled like this. So you get cancellations like this. And you have 3 terms remaining at the top. So obviously by symmetry you get 3 terms remaining at the bottom. So what is the sum of n terms? So the sum of n terms is nothing but tan inverse 0, tan inverse 1, tan inverse 2. So these 3 terms are left out here. And what will be the 3 terms left on this side? Tan inverse of n plus 2, tan inverse of n plus 1 and tan inverse n. So tan inverse of n plus tan inverse of n plus 1 plus tan inverse of n plus 2. So these are 3 terms which are left on this side, minus tan inverse 0 minus tan inverse 1 minus tan inverse 2. So this is the sum up to n terms. But now I want sum up to infinite terms. So sum up to infinity is nothing but limit n tends to infinity, this expression. So as n tends to infinity, so tan inverse n becomes pi by 2. N plus 1 also tends to infinity. So this is also a pi by 2. This is also a pi by 2. So you get 3 pi by 2. Tan inverse 0 is 0. So this gets cancelled. Minus of tan inverse 1 plus tan inverse 2. So what is tan inverse 1 plus tan inverse 2? So what is the formula of tan inverse A plus tan inverse B? Or you can directly write tan inverse of 1 as pi by 4 minus tan inverse 2. So 3 pi by 2, 270 degrees. 3 pi by 2 is 6 pi by 4 minus pi by 4. That is 5 pi by 4 minus tan inverse of 2. So this will be the answer to this question. Or you can write as 5 pi by 4 minus cot inverse of 1 by 2. So this will be the required answer. So but the given options are this. This answer does not match with the options. So how do we try to match this answer with the options? So in the answer, if you see the first option, it's in the form of cot inverse 2. So let us try to convert tan inverse 2 into cot inverse 2. So we have the formula, we have an identity which says that tan inverse of x plus cot inverse of x is equal to pi by 2. So tan inverse of 2 can be written as pi by 2 minus cot inverse of 2. Pi by 2 minus cot inverse of 2. So if I substitute it here, so I get 5 pi by 4. 5 pi by 4 minus of pi by 2 minus cot inverse 2. So 5 pi by 4 minus 2 pi by 4, that is equal to 3 pi by 4 minus of minus is plus cot inverse of 2. So this is exactly same as 3 pi by 4 plus cot inverse of 2. So option A is the right answer to this question. Thank you.